for the flow level thing here, how flow does work between the sides or between the leaves. All these things I'm going to talk about today. Okay. So ACI does support 4 types of topology here. Okay. If you can see, just give me a second. ACI does support 4 types of topology here. First is single port, second is a stretch fabric, and third is your multi-port, fourth is your multi-site. Okay. So what is the advantage? What are the use cases of these terminology, or you can say these technology in ACI? Why should we use multi-port, multi-site, or instead of going for other thing? Okay. So if I talk about here, and there is a limitation in ACI how you can connect with each other. Okay. So leaf to leaf, you cannot connect directly. Leaf to spine only you can connect. Even the spine to spine you cannot connect, right?
Yes.
So just give me a second. Where is that topology? Just give me a second. Okay, so if I talk about here, 4 topology ACI does support here. Okay, first is your a single port,
Okay.
single port, single port, and second is your stretch fabric or stretch fabric. When this particularly supported in prior to 3.0. Okay.
Okay.
And even now you can do that, but before 3.0, this, if you have multiple sites, in that case you need to have the stretch fabric to interconnect the fabric. Okay. Now after from 3 sorry, from 3.0 onwards, multi-port came in the picture. Okay, multi-port in the 3.0,
Okay.
and in the 3.0 also it came multi-site feature here. So basically we also call it dual fabric one fabric. Okay, so dual fabric you replace with the multi-site. Okay, and the stretch fabric now is replacing with the multi-port here. Okay,
What is this dual for fabric? This is
yeah, I will talk about that. Just give me a second. Here is good example. If I may have it, otherwise I have to draw it. Okay, let me draw it here. Okay, so I will first go with a single port. Okay, we have one.
okay.
Just I will take one spine, one two leaf. Okay, this is, we call it single port.
Hmm.
Okay, we call it
Okay.
single port. You have just one server and whatever you have, these are connecting here. You are not sending anywhere your traffic. Okay,
Yes.
even if you have 10 location, you can connect like this single port. I will talk about the stretch fabric. Now you have the multi-port. Suppose you have the 2 location. Okay, suppose you have 2 location here, and one is in here and here. This is the leaf, and another is here. Okay, so suppose this is how it connecting. Okay, and you have like this site 1, site 2. Okay,
Okay.
now you want to you are running the below to 3.0 version. Okay, ACI. Now even you can connect that. Suppose you want to activate your DR kind of things, right? How you can connect 2 sites? Because prior to 3.0, you had no concept for the multi-port multi-site, right? So what we had feature here, leaf to spine and spine to leaf. This is how you cross connect it. This is how
Hmm.
you cross connect it in stretch fabric I'm talking about. Okay, this one, stretch fabric.
Okay.
Okay, this is a single port. Now, if I talk about the stretch fabric, means you have here DWDM or dark fiber you can use for interconnection. But make sure port 1 leaf should connect with the port 2 leaf, and port 2 1 leaf spine switch should connect to port 2 leaf here. So leaf to spine connection is happening. Leaf to leaf connection is not, you know, establishing here. So in this case, even your
Yes.
cluster will be sync here. If you have one epic here, one epic here, it can form the cluster because you have the interconnection fabric right here. So that's why we call it here stretch fabric is replacing with the multiport. Okay, multiport is the one who is replacing the stretch
So
fabric
this is
because
the stretch fabric, huh?
stretch fabric. Yeah. So this leaf will known as a transit leaf here between the two sides. You can use any public network here or separate lease line for interconnection. This must be the 10 gig or 25 gig or 40 gig. Okay. And even the prior to 3.0, you need to have the 40 gig. So usually we recommend to have the 40 gig minimum between the leaf and spine, right? So this is kind of a bit
Okay, this is
costly.
for the stretch fabric, right?
Stretch fabric, yeah. This is stretch fabric. If I talk, because since you have this flexibility here, right? Since you are running the single management plane for your the entire two fabric one through the stretch link right here. Now Cisco came up with a multi-port. Cisco saying, okay, if I'm connecting
Yes.
leaf to spine here between two sides, why should I not integrate spine to spine connection, right? Instead of leaf to leaf connection here, why I should not go spine to spine connection? Why this kind of mess here, right? If suppose something happened with this public internet DWDM link or dark fiber link, your entire fabric will be isolated, right? Even though your cluster will have the also issue here because of this link, right?
Yes.
Now Cisco came up with the multi-port scenario here. In the multi-port 3.0 version, Cisco introduced multi-port where you have the L2 L3 extension through the spine switches. Okay, so here Cisco came up with the spine multi-port concept here. Okay, so suppose you have two sides here. Okay, you have side to one, side two, and you will have the here one router sitting here. Okay, so we call this IPN device interport interport network device. Okay, or you can say interconnect port network device, where you have the connectivity from the your spine switch. Okay, for L2 L3 extension here, and instead of connecting to each other from the leaf to leaf between the sites here, now you do not have any interconnection from here to here. This connection you are losing here now. Okay, so this is actually good practice here to not use the this kind of scenario, but multi-port replace the your stretch fabric here. Okay, this is the your multi-port here. So in this case, what is happening here? You will have two epic here and one epic here. In this case, also you have single management plane for your network. Okay, you're not replacing the management plane using the multi-port scenario. Just like a stretch fabric, you have single management plane right here. You will have the one epic, two epic sitting here, one epic sitting here. Kind of, you can use more than two epic, one epic. Okay, just I'm giving the example here. So this is how you you instead of so all the three epics are interconnecting or connecting through this stretch link right here. Now in this case, you have the IPN devices where your
Yes.
all the epic discovery and the epic cluster forming and sync up will happen here. So both data center will act as active here. Okay, so you will have the active data center with the single point of the management interface or management controller. I would not say separate control plane data plane. I would not say single control plane data plane, okay? Because these devices are separate ports, right? They are just a single acting as a single management plane, okay, for your network. Now this is for the limited geographical location. Suppose you have one data center in suppose US and one data center in New York, okay. So this is for the limited kind of uh, distance here, okay. Suppose you have one data center in US, okay, US. Second data center is India. How you gonna come? You know, in this case, you have certain limitation in multi-port. Like AP cluster distance should be this much. Okay, I don't remember the exact number, what kind of distance it support, but there is a limitation. Like up to this much kilometer, you cannot connect IPN or you cannot connect stretch. You know, your control plane, right? So this is kind of limitation. So now Cisco came up with the multi-site concept here. Okay, it means you will have the single data plane, a control plane, and manage. Hello.
Hello. Yes, Vijay.
I don't know why it's fluctuated. I'm not sure why. Now you can see, right?
Yeah, I can see the.
Okay, sorry. I think my internet fluctuated. Okay, so now I'm going to talk about the multi-site here. Okay. In this scenario, you have the two data center. You have the one you can say cloud network here. Okay, and you will have the one. Sorry.
So regarding the stretch fabric,
Mhm.
it should be within the city itself.
Exactly. So there is certain limitation where you can not exceed that much. Okay. I don't remember the exact number kilometer. Okay. Let me try that. Why should not try that? ACI stretch. Okay. This is how your stretch fabric connect. I would say limitation. Okay. So I think here we can find out that. Sorry. Okay. Let me check that. This is how they connect, right? One leaf to one spine, one leaf to one spine. There is no leaf to leaf connection. Okay.
Okay.
So I think there must be limitation. Okay. So this was recommended for 2.3 release supported. Okay. And there is like look here. So 30 kilometer, I think. So depend on it. Since we have 40 gig supports here, it support only for 30 kilometer right here.
Okay.
So, and this much should be latency 50 millisecond, should be RTT for your between the network. Yeah, so there is a software limitation which is 30 to 40 kilometer for QSFP. If QSFP is not supporting more than 40 kilometer, then I think that limitation should also match with the that thing, right? If you are using the DWDM, so 800 kilometer is the 100, right? 800 kilometer.
800.
Yep. So yep, look here. So you can use metro fiber or we can use DWDM. So you can stretch the fabric up to 800 kilometer. Okay, not more than that. If they have not enhanced it in the new release. Okay.
We are using the dark fiber, then only 30 kilometers.
If they are not using if they are directly connecting, right, like the leaf switch to spine switch, so there is a
Yes.
SFP limitation. You can directly connect with leaf to spine with 30 kilometer, 30 to 40 kilometer. Okay,
Okay. Okay. That's because of the SFP.
exactly. If you have the in middle of the two sides, if you have some other devices, you can connect and rest all the things they will take care about it, right?
Okay. Okay.
So
Like
yeah.
DWDM.
Exactly. DWDM or dark fiber, you can use UMPLS pseudowire, you can use any L3 technology which support MPBGP, VPN, or VXLAN, right? Transport here. Sorry. So yeah, so this is the multi stretch fabric. If I go for the multi-port here, multi-port limitation here. Well, it's important that if customer requires something, right, you need to know that how much it can support here. ACI port. Sure, yeah, scalability, deployment. So up to this much you can connect that. Look here. So what I was talking about here, stretch fabric is replacing multi-port is replacing the stretch fabric, and your dual fabric is replacing uh, AC multi-site is replacing dual fabric here. Okay. So I will tell you that how they are replacing that. Uh, there must be the uh, there 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 are you can say frequency should be less than 50 millisecond for the all the multi-port and multi-site. Okay, if you have more than uh, a 50 millisecond RTT, then your probably your cluster will not work or something you will face in the network here. So make sure the latency should be very very less for your network here between the ports. Okay, and this is the number which can support that, like about 200 leaf switch you can connect in a single port. Okay, in a single port up to 6 spine you can use per port. Okay, in the single port you can use 6 spines, but you cannot exceed more than 200 and 6 spine more than 200 leaf. There is a limitation, and this limitation is keep rotating, keep changing here. Okay, so if you have 3 epic, it can support only 80 leaf and spine switches, including leaf and spine 80 total. Okay, if we have 3 plus 1 4 epic in the 4.0 you're running. Sorry, hello.
Yeah, I can hear you.
Yeah, so here is a four nodes. I mean to say 3 is active, 1 is standby. Okay, these 4 nodes will not be
Okay.
added active, will not work as a active. Okay, so you can install like 200 leaf switches. If you have 5, usually in the production for the big kind of production, whenever you use multi-port kind of things, where we usually recommend 5 to 7 epic here in overall multi-port scenario. Okay, and
Okay.
there is also like 900 800 switches you can connect, and their maximum port can be the 12. It means 12 data center you can interconnect with each other. Okay, maximum ACI for multi-port. Okay,
Okay.
and I'm not able to see that kilometer thing, right? How, what should be the distance, minimum distance, something like that. Okay, so I'm assuming that it will be the more than, or it will be the similar to 800 kilometer, right?
Yes.
Since it is replacing the stretch fabric here. Okay, so so sorry. So this is the replacing this one. Now Cisco came up with, after this multi-port scenario, Cisco came up with the, actually the thing is this multi-port was not introduced when dual fabric came in the picture. Okay,
Mhm.
like this was also not very much good for the production, because if anything will happen your entire site can be isolated right here.
Yes.
So in this case Cisco came up with a dual fabric. It means leaf to leaf connection. So let me draw it here. How you can provide the leaf to leaf connection? Suppose you have suppose you have two fabric here. So this lot of customer are using even in the current 4.0 version. Okay, even I
Mhm.
deployed for one of the big customer in Japan. Like more, they have more than 1,000 leaf and spine switches total. Okay, so in this scenario, what used to happen here? You can connect like this. You can directly connect, or if you have the distance, you can interconnect with the any L2 L3 switch. Okay, L2 L3. So this is how you can connect your. This is, we call it dual fabric. Dual fabric. What is the meaning of dual fabric? It
This,
means you have the active or DR side here. So this can be your active and DR. In the stretch fabric, you will have the active only. Okay, you cannot do that. You can do the active and kind of a standby, host level kind of thing, failover, HA kind of thing, but you cannot do that, active standby or DR DC kind of a scenario in the stretch fabric here. Okay, so what is the meaning of dual fabric here? You will have the separate controller here. Okay, for the each fabric, you will have a separate API controller here. There is no dependency for any control plane, management plane.
okay.
Okay, you will have the all single controller here. They will not talk to each other. Okay, so only services will be synced between these two sites using this L2 L3 extension. Okay, this is, we call it a dual fabric now. Now Cisco came up with here, say why we should not use any. Suppose in this case you are increasing your operation thing right here. You need at least
Yes.
suppose you have US, you have India. Suppose you have to, something is happening in the US data center. So one engineer should be present in the US, one engineer should be present in the India, right? For the each data center. So
Yes.
this will increase the your complexity of your operation thing, and even increase the operation cost, right? So Cisco came up with the site, we call it a multi-site scenario. So Cisco what did here? Cisco says, okay, I have the orchestrator, epic orchestrator. Okay, so these all epic will integrate with a single orchestrator. Okay, through internet. If your epic, your this one is reachable, epic management IP is reachable towards the internet, you can connect with the orchestrator. We call it MSO, multi-site orchestrator. It means all the sites, suppose you have 5 sites right here. So all the 5 sites epic will integrate with this single orchestrator. Okay, this orchestrator will configure your configuration towards all these DCs. You can configure even a single kind of template. You can configure the global template. Global template means same stretch configuration. Okay,
Mm.
so this enables a lot of flexibility in the operation cost.
Where we will keep this
Okay, so
multi-site
okay,
process?
so MSO is just a VM. Okay, it's not a physical appliance. You can have the you can purchase the physical appliance with the server, but it doesn't come with a dedicated hardware. You can install anywhere. Okay, even you can
Okay.
install in the LAS, you can install in the PAS. Okay, you can install in the SAS. So it can be deployed anywhere in the cloud, in the on-prem, okay, data center.
Mm.
So the more motive of this multi-port and multi-site scenario here. So port enables your single fabric extension. It means, as I told you, active data center. You will have the single point of control for your 2 data center. Okay, and you will have the local ISIS and COOP instance. It means you will have the some separate control plane and data plane protocols. It means your data plane or control plane is not syncing, only management plane of, you can say, policy manager is syncing that. Okay, so single point of administrator you will have here. So you can stretch here the your VMs here. Okay, you can stretch your firewall between them. One can be active, one can be standby, but usually this we multi-port deploy for the active data center. Okay,
So we can also design it as active and standby.
in this case you can do that, but that can be the services. Okay, you can do that. it's not like you cannot do that. You can do that, but this is actually the uh, single point of failover, you can say. It means this multi-port will act as a single availability zone. Okay, you will have the only single point of controller. Suppose you have 4 sites, right? 2 sites you want to use as a control plane. Suppose you want to use 2 sites as an active data center. Okay, and one site you want to keep as a backup for this activity data center. If something happened to this data center, our backup should come up, right? In this case, multi-port is not recommended. Okay,
Okay.
you can stretch that fabric here. Single management plane you are getting, more than 2 activity data center you are getting here. Okay, if we talk about the multi site here, so multi-port we use IPN devices. Okay, these are the Nexus devices. There is certain limitation in I would not say it's a limitation. There is certain
Mhm.
requirement for these devices. Okay, you need to, your device should support OSPF, DSCP, IGMP, multicast. So these are the basic feature which your multi-port does support or should support. Okay, IPN devices. If we talk about that multi-site here, so you will call it ISN, inter-site network here. Okay. In this
Mhm.
case, suppose this is your data center. This is your multi-port, right? Where you have single point of API here. Now you want to keep one data center as a DR. Okay. Suppose this is the DR. This is your DC. Sorry. This is your DC. Okay. So if you suppose your requirement is once your active data center, both will went down, so make sure your DR should come up. Okay, in this case we usually
Okay.
recommend to have the multi-site or multi-site deployment here through the ISN is just a layer 3 device. It has nothing like such as it should support IGMP, multicast, and DSCP. No, it can be any layer 3 out device, any L3 device. Okay, for interconnection. You can use even internet
So
devices.
what protocols will be using, routing protocols between them?
Only OSPF does support as of now between spine switch to any device here. I,
Okay.
OSPF and MPPGP. So you do not need to configure MPPGP on these devices, IPN and ISN devices. Okay, you
Mhm.
can directly just configure the OSPF between here to here. So MPPGP will form between the data center here. If you check here, MPPGP EVPN only form between the intersite here.
Okay.
So what the advantage of connecting here? Sorry. So multi-site orchestrator extend the policy domain across the your multiple API cluster domain. Okay. So you will have the your global multi-site orchestrator, as I told you that. Okay. So this device will connect your inter your all the DCs, whether it's a multi-port, multi-site. You have more than 6 DC, 5 DC. Okay. So all the DC you can manage through the MSO only. Okay, this is we call it the multi-site orchestrator, and it also simplify your network here. Okay, and
Okay.
so this is the main advantage. You can see the operation consistency. You can see that, and policy translation. There is also uh, done by the MSO, single point of orchestrator. Okay, independent availability zone. Okay, see, in this case you do not have independent availability zone. Okay, you have single point of orchestrator right here. It means they belongs in the single availability zone right here.
Yes.
It means if something happened to one policy controller, it will impact both the DC, right?
Yes.
But in the multi-site, suppose you have four sites here, if something happened to one DC, it will not impact your other DC, right?
Yes. True.
So this is the main advantage, I would say, independent availability zone. Suppose I preparing that one question here. So this is the our question here. We have 4 sites, okay? 1, 2, 3, 4. This is one of
Mhm.
my customer. which I'm designing. Okay, so they have 4 data center A, B, C, D, and they have 2 remote site. So what they want here, they already purchased the ACI, and they want their A and B should be act as a active data center. Okay, and what the existing
Okay.
services they are running in the A and B, they have the stretch uh, services such as the single VMM domain they have in the HA mode, and they have a stretch cluster firewall between them. Okay, so that kind of active data center they are running in a single availability zone. Okay, so site C will be the backup DC if A and B both will be unavailable. Okay,
Okay.
so since so site C will be totally your DRDC. So I'm representing site C, this one. Okay, A and B is a in a single availability zone. Since they are running the stretch kind of thing here, they are in the single DC. Okay,
Okay.
and the site D is migrating somewhere. We don't have information. Okay, and the between the data center latency is very low, less than 5 millisecond. It means data center destination is location is not much far. Okay, and the
Yes.
remote sites have these services, radius servers, DNS, DSCP services. These small shared services are running in the uh, remote site. So they have 2 remote
Okay.
site, and data center A and B consuming these services from the remote site only. Okay, and the customer sorry, customer main concern is single point of management for 2 data center. Okay, A and B should be single point of management. Okay, A and B. So you can have the
Okay.
single point of control management using the multi-port scenario. You are getting the or
Yes.
stretch fabric. There is 2 options for single point of management. Okay, and need availability to manage remote site as a part of the A. They do not want to change anything in existing data center. Okay, they are not planning to migrate anything. Just they want to use their existing services with the A and B from remote site. Okay, now second requirement is require an isolated control data plane management plane for the DCC. Okay, if you are using the multi-port, you are not fulfilling the requirement right here. You have the
Yes.
single management plane, a single management policy controller here. So you are losing that concept here, right? So for
Yes.
DC3, DCC here, they need separate isolated control plane data plane, even the management plane for the network. Okay, and treated as separate availability zone here with the
Okay.
L2 and L3 here. So now the overall picture is customer requirements, all the A, B, C, D data center should be controlled from single interface. Okay, paths are the access the control data management plane. Okay,
So we need to go for the multi-site here. Multi-site with
exactly,
MSO.
exactly. So they have 2 data center with the multi-port. So we have to go with the multi-port over multi-site. Okay,
Yes.
this is the scenario. They are saying they want single point of management plane for the A and B right here. So port
Yes.
1 is representing A and port B is representing B. Okay,
Yes.
so they have single point of configuration here. Now they want separate uh, separate availability zone for the DCC, right? The requirement is.
Yes.
So you can achieve this using the multi-site only. If you want to have the separate availability zone, because if the moment you will go for the multi-port scenario, you are sharing you're losing your independent availability zone scenario here. Okay,
Yes.
so this is the higher level of overview. Now the requirement is remote site, right? In the remote site, they are
Yes.
hosting these services, common shared services. Okay,
Okay.
so how you will connect your remote side with these spine and leaf switches right here,
Yes.
because A and B both are consuming these DNS and DSCP and your DNS or in whatever they have AD values, they are consuming from to remote location right here. So
Yes.
now what I'm going to suggest here, since you have site 1, site 2 here, and they are consuming the some services from a remote site. So now I will go for the remote leaf concept here. Okay, you can deploy
Okay.
the remote leaf. What is their demand here?
Okay.
Need
Need everything
ability to
managed
manage.
outside, part of DCA and B. Just to need
Exactly. So
everything.
they are saying even remote site I want to manage from the same management controller, which are using an A and B, right?
Yes.
So since there is a less requirement, they have less services in the remote site, we can just deploy the 2 leaf switches, right? And these 2 leaf switches, you can run the any L3 protocol such as OSPF, DSCP. There is certain configuration which you can directly connect with the internet switch. Internet must be reachable from the IPN. Then the moment you will deploy the remote leaf and form the neighborship with the IPN, you can discover from the these ports, multi-port controller. This is we call it the remote leaf scenario here. Okay.
So remote leaf doesn't need to be directly connected to the existing DC leaf, huh? It's fine.
No. Not directly. You can deploy anywhere. Just 2 leaf. You do not need even any kind of controller.
Okay.
Just 9K device. Just connect your two interface towards the interface internet and use the any protocol. And we will give basically ACI give the particular VLAN. Okay, this is my IP. You can use this IP. Just form the neighborship over the internet, right?
Okay.
So in this case, even remote site can manage by your APIC here.
So they will be automatically discovered once they have the reachability
Not
with the.
automatically, you will have to discover it through the APIC.
Okay.
Okay, and the advantage
So
of this, yeah,
they will be having the same tape addresses,
no,
same.
we can assign even same, or else usually we recommend to have a separate tap address.
Okay.
Okay, so this remote switch also provide that in since 4.2 we have something called it uh, remote site failover kind of things. If suppose one site is been down, okay, site B is been down, site 1 is active, so remote site will not be have any kind of impact. This introduced in the 4.2. It means your remote leaf will be automatically switched between the A and B if any kind of failover happen in the data center. So you are getting the better kind of high availability for the remote site event right here. And for
Okay.
that you need to use the you need to eliminate the route refactor instead of full mesh. Okay, you need to use the route refactor full mode instead of full mesh mode configuration in the ACI. Okay, so this kind of things which we usually recommend for the any customer. This is just a high level overview. Okay, I'm not talking about
Okay.
any kind of traffic flow as of now. Okay, so this is how we connect the sorry. Okay, hang on a second, just give me a second. Okay, so this is how the two more than two sites connect here. Okay, this is how the physical connectivity looks like. You your this cloud is representing your in any of the your internet device or anything, you can say that. And these devices are IPN devices. Okay, these devices are IPN devices. So these IPN devices should support PIM mode, DHCP relay, and Jumbo MTU. These are the prerequisite for the IPN devices. For ISN devices, for ISN devices, only the Jumbo M2 is required, or it will just act as a L3 device. Okay, for ISN. Is that clear?
Yeah. So what will the default MTU on the ACI switches?
Default between the fabric, it will be the Jumbo M2, but for the external layer 3 out, it by default is inherit. It means nothing will set, you have to set it. And since the
Okay. So,
VXLAN packet doesn't support your IMSS kind of things, you have to go with the Jumbo MTU. Okay,
so
always.
what is by default MTU and what Jumbo MTU we need
So
to set?
default M2U is 1500. By default is inherit. Inherit means in ACI, you will have the auto negotiation with your neighbor device. Suppose you one device is connecting here, okay? So by default, if you set inherit in ACI, it will automatically sync with the neighbor device MTU.
So by default is 1500 or 9000?
No, no, 9000 is between the leaf and spine, where you have by default
Okay.
your IS and VXLAN is running, okay?
Okay. Mhm.
Not your for outside. For the fabric interface of a fabric network, you will have the Jumbo MTU by default, okay? Because
So
your even
9000
the
Jumbo MTU.
yeah, so even the BGP doesn't by default set that don't fragment, right?
Yes.
Don't fragment bit. So your even BGP by default, discard your fragment packet here. So that's why it support the your MTU Jumbo MTU. Even the your I think VXLAN has more than 42 bytes here. If you are going with the normal M2 size 1400, 1500, it will create the problem, intermittent problem. Okay, is it clear?
Yes.
Where is that? Just give me a second. Disconnected. Okay, so let's talk about the flow here. So you got this, concept of the 4-5 designs of the ACI, right?
Yes.
So let's talk about the how they work. Okay, this is just an overview. Now I'm going to talk about how these sites work with each other. Okay, so let's take example of the single port. Okay, I'm going to talk about just a simple example. This is a day 0 configuration. Okay, sanity check of the first packet will be your LLDP. Okay, how this LLDP will work here. And then DSCP server, your EPIC will be the DSCP server for your network. ISIS work
Mhm.
between the leaf and spine. Okay, and certificate validation does EPIC does the certification validation for your network here. Okay, DMU is always support a switch version. FSM, you can say that. Okay, so this is how the discovery happened. So suppose you have the there is a 6 or 7 flow. After this 6 flow, your VXLAN neighborship start establishing between the leaf and spine, or leaf to leaf. Okay, once these sanity test, these all devices pass. If any of the sanity
Okay.
test is failed on the leaf switches of particular devices, though that particular device will not be part of the your fabric. Okay, if I
What
suppose,
is
yeah,
DME? DME?
that is the process for your switch, which usually check your the firmware. I don't remember the DMU full form, but that is the engine something which check your version compatibility between the leaf and spine and APIC here. Okay.
Okay.
So suppose you're running one switch is running at 2.0, another switch is running 3.0, 4.0. In that case, your compatibility issue will come in the picture, right? You have to check whether backbone compatibility is supported or not this particular version. If not, then your process will not initialize for the VXLAN internally for that particular device. Okay.
Okay.
Okay. So this is how the L2 flooding work or L2 traffic work. This is them taking just a simple way. Okay. Suppose you have two end host is connecting here. Two VMs are connected with it from the single port. Okay. I'm not talking about multi-port, multi-site here. Just single port. Suppose example L2 packet. Okay. Suppose you have one VM which is running the VLAN 100. Okay. The moment you connect with the APIC, your ACI here, your first packet will trigger to the your leaf switch. Leaf switch will trigger to spine switch using the COOP protocol. Okay. So COOP protocol is the one who update the data endpoint database with the spine switches. Okay. And on the particularly the moment your L2 traffic hit on the leaf switch here, leaf switch will check this table here. It will check bridge domain. This particular VLAN belongs to this bridge domain. Okay, this is the MAC address. This is the interface. This is how your entry looks like in the endpoint table. Okay, if you'll check in
Okay.
the endpoint table, so endpoint in the on the leaf switch, your leaf switch will say, okay, this is the I have entry here. VLAN information, MAC information, from which interface it is coming. Okay, if the moment your packet is installed, it will share with your spine switch. In spine switch will install that address in the COOP database. Okay, or you can say proxy table. Both is the same. Okay.
Okay.
If suppose this packet is known, okay, this is just a unicast packet I'm talking about. Suppose your spine know where is your destination, even your destination have this source entry and all. Okay, so your first packet will hit in the leaf switch. Leaf switch will encapsulate with the outer IP and outer header here. So what will be the outer IP? Outer IP source IP will be your leaf tap address. Okay, so there is a packet type here, inner header or outer header. You know that inner header or outer header. Let me share that. I think
No.
I have here only. Just give me packet header. Where it is? Okay, no problem. Just not waste time here. So VXLAN header. Okay, if I talk about here inner and outer, what is the inner header? What is the outer header? Okay, here. Uh,
Yeah, just give me a minute.
yep, sure. I was talking about here the header of this VXLAN right here. If I talk about here, so inner header and outer header here, if you'll check here, this is the your normal VXLAN packet. Okay. So if we'll count that, what is the length of this? You can see that here 20 bit, 20 byte, 18 by 8 byte, 8 byte. So how much is packet length here?
20 by 20, 20.
I think it's going to be more than 40 byte, right?
Yes.
So what is the outer MAC address, outer IP header, and outer UDP and the VXLAN header here? Okay. So there is a this is original frame. Okay, this is the original frame. So the moment your is leaf switch, the moment your endpoint will hit in the on the leaf switch will separately create original packets with the source address, destination address, and all the things. Okay, of the
Okay.
endpoint of the VM host IP address. I'm talking about. Okay, here. Okay, so the moment your traffic will hit on the leaf switch will what leaf switch will do? Leaf switch will add the VXLAN header here because between the leaf and spine only VXLAN work, right? So C to VXLAN convergence will happen on the leaf switch. This is we call it encapsulation. In the outer header, leaf switch will add destination MAC, source MAC. Source MAC will be your leaf tap address, leaf MAC address. Okay, this is the pure L2 I'm talking about.
Okay.
Destination will be your, if it is known, then it will be the destination leaf MAC address, tap MAC address. Okay, this is the VXLAN type, VLAN type here. It means this is suppose this is the usually change if it is ARP request, this type value always change. If it is a ELF IPv6 packet, this always change. If it is Ethernet packet, this always change. Okay. So what is the VLAN ID tag? If it's suppose VLAN ID is 10, right? What is the type of the Ethernet here? We are using Ethernet. We are not using any kind of multi-fabric and all the things. Okay. Or we cannot. We are not using any FC interface or other interface. We are using just Ethernet interface. Okay. What will be the IP header here? This is L2. Okay. Now if you come for the L3 here, so what will be the yes, outer source IP? Outer source IP will be your leaf switch IP, where your local VM is connected. Okay. What is the outer destination IP? Your destination leaf tap address. This is talking about for unicast packet. Okay. What is the VXLAN header here? VXLAN header add your UDP port here. UDP port here 4700 something. Okay. 4738 something. I don't remember the exact, but it is 4700 UDP packet. Okay. Where you have the VXLAN port here. This is the just a checksum. Okay. And what will be the in the packet of the VXLAN header here? This will be the UDP header where you have this VXLAN packet, because leaf to leaf there should be the one particular protocol which should be the responsible for the data plane communication, right? So for data plane communication you will have the UDP protocol here with the VXLAN. So VXLAN is the responsible for the data plane communication between the two devices or two leaf switches, which will work based on the port number 47 UDP. If you check the VXLAN header, you will have the reserve bit, you will have the VN ID. It means suppose VLAN 100 it coming from outside, right? It will automatically convert into the VXLAN ID, VN ID. Okay. So and there will be the 24 bit length for the VXLAN, right? This is the 24 bit VN ID.
Yes.
Okay. Is this clear? And this is just a frame checksum for the your frame check sequence.
What do we have in outer IP header?
Outer IP header, you will have the tap address of the source leaf and destination leaf. If it is a unicast, okay, your original packet for the L2 frame will be the same what hitting in the leaf switch. Leaf switch will not do any kind of this and that with the your original frame. It will just add the extra over payload on your original packet here. Okay. Is it clear?
Yeah, yeah.
Okay. So I was talking about this scenario, okay, this particular scenario. Okay. If you'll check here, outer source address is your leaf one, right? And
Yes.
what is the destination? Destination will be your tap address of your leaf.
Okay.
Okay. So this will be the your normal unicast packet forwarding. Okay. Is this clear?
Yes.
Okay. So let me give you some of the example. How many loopback or tap address present in the ACI? So there is a multiple tap address which epic assigned to each leaf and spine switches. Okay. So each tap address will have the separate unique responsibility here. Okay. Where it is quite lengthy document, so I'm sometimes I get confused here. Where it is? Just give me a second. Tap tap. Hmm, let me search. Okay, let me check loop back. Okay, so here we go. So this is your is the fabric discovery day 0. Okay, so here it was. So look here. So you assign the tap address in the leaf switches on the epic switches, epic device right here. Suppose you assign 10.0.0.0
Yes.
slash 16. Okay, so always this is I'm talking about the leaf here. So there is a 4 IPs which usually assigned by the epic here per leaf switches. So tab 0 will be your p tab. Okay, this is the p tab. What will be the use of p tab? I will talk about. Loopback 0 will be always BPC anycast. Uh, you can say VPC virtual IP address. Okay, and loopback 20 will be the F tag, and this will be the used for the off-flex discovery. Off-flex is the protocol which usually run on the epic for the third-party device integration. Okay, and if we talk about the one SBI always assigned by the epic, which we call it the DSCP relay. Okay, and uplink will be unnumbered for the loopback 0 from this IP. From this loopback, your all the leaf switches will have the IP address for the uplink interface, which is connecting towards the leaf switches, spine switches here. Okay, so there is a by default how many address epic assigned to leaf? 4 address. Okay, one is a P tab, physical tab. You can say that, which all the your suppose you have two spine switches or 6 spine switches right here. So each interface will get the IP address right to form the neighborship, this leaf
Yes.
interface. So this
Yes.
interface IP address assigned by the PTAP loopback. We call it unnumbered, right? Unnumbered
Okay.
command is old, but it is useful for the internal programming here. It means I'm borrowing the IP address from the loopback 0. Okay, is it clear?
So loopback 0
Your voice is breaking. I'm not able to hear you.
is loopback 0. Yeah, loopback 0 will be created where?
On the listen. So this is the discovery, right?
Yes,
The moment your LLDP will discover here, so your APIC will always detect DSCP server, right?
yes,
So DSCP will assign the IP address to these switches, right?
yes.
So APIC always assign 3 to 4 IP addresses, loopback addresses to these each switches from the range whatever you have given in the tab pool.
Okay,
Okay, so this APIC is the responsible to configure these all the IPs on the leaf and spine switches. In spine switches, there is a separate concept, but in the leaf switches there is a tab concept. Okay,
okay,
here PTAP means loopback 0 means your APIC will assign this loopback 0 for all your physical interface unnumbering. It means if you
okay,
suppose you have 6 spine, where this 6 spine will get the IP address from this tab loopback 0. Okay, and if we talk about that after discovery, always spine between leaf and spine, you will have the neighborship. Okay, so always just make sure here you will get the sub interfaces. You will never have the physical interface neighborship between leaf and spine. Okay, and there is a interface which you can use between the leaf and spine. Okay, not all the interface you can use between the leaf and spine.
which interface we can use only?
49 to 52 usually, which are the
Okay.
some which are fabric port, you can say, just like 2K devices.
Mhm.
Okay, there is a maximum 6 interface per leaf switches. It means 6
Okay.
spine you can connect you in your network, right? 6 port means that, and each interface will have the capability to support 40 to 100 gig link up to your your, you can say, SFP. Okay, if we talk about that spine switches here, so how many interfaces spine switch get here? So look here, one loopback 0 is a is regular for all the leaf and spine switches here, which APIC assign it from, because a loopback 0 is the responsible for the physical interface IP address assignment, right, in within the switch here. And
Yes.
this is the loopback which usually used by the COOP protocol. Can
Okay.
be loopback 40, 16, 18. Proxy loopback say. So between how the trigger or sync up happen between leaf and spine. Suppose one endpoint learn in the this leaf, how this leaf will trigger to this spine using what? There will be the protocol, COOP protocol, but what will be the IP address for the COOP protocol sync up, right?
Yes.
Because you cannot use a physical interface IP address, because physical interface IP address is using for the control plane
Yes.
synchronization, right? So you will always go for the uh, this.
Loopback 14, 16.
One second. Yep, sorry. So this is for the COOP synchronization. This is also, we do not have any control over this IP address assignment. Okay,
This will be assigned by Epic only, yeah?
this is all things happen by the epic. Okay, we
So
do
what
not have
IP will be assigned to this loopback? 14, 16.
loop. Okay, so suppose you assign tap address 16 10.0.0.0/16, right? From this
Okay.
range, all these loopbacks and all the things will be created in IP address will be assigned from this actually range, because APIC will have this DSCP range, DSCP pool range, where from this particular IP address range, all the epic will get the IP address. Okay, so epic always assign IP address slash 30 for loopback 0. Okay, just to keep
Yeah.
in mind, always 32, just one IP, one or two host IP. And sorry, so and what will be the 13, 15, 17? This is the any cast for all the spine using to trigger kube lookup here from the leaf switches. This is for the database synchronization. Okay, suppose any unknown packet come in the leaf switch, right?
Yeah.
So how this leaf switch will request to kube device. Okay, suppose any unknown packet, this unknown packet come here. Okay, and suppose this leaf doesn't have any kind of entry for this particular host, right? So it will always trigger to spine switch. Okay, do you have this entry in your kube database? If spine has it, then it will say, okay, I have it. Okay, so in this case, this is the loop back which usually we use. Okay, this is, we call it any cast IP address, we call it here. Okay, this is how you can check it, you know, in the spine switches. This is the command. Here you can check that. If you can say show IP interface brief, you will get it, the information that this is the anycast. Look here, this is the overlay uh, p-type address, all these things you will get it here. Okay, so I will check that. Let me check that if I have the access. Okay, seems like it's down, port is down. Okay, so this is how the communication work between the leaf and spine switches. Okay, is it clear for you?
Yeah, clear.
Okay, and this is your normal just a unicast. If I talk about another flow here, okay, I was talking about just known traffic. Okay, this is just a normal your ingress switch and egress switch. Egress switch always do the decapsulation. Ingress switch always does the encapsulation of the VXLAN. Okay, so encapsulation will happen on this switch. VXLAN encapsulation will happen here, and the decapsulation will happen here. Okay. If I talk about the here lookup and perspective, this is the theory part, command line part, which I will talk later. Okay. Just I want to
Mhm.
make the clarification before we go for any kind of practical. Okay, how the normal packet behaves, we'll
Okay.
recover it again. Okay, and what if you have L2 unknown packet? Okay, this is your unknown packet. It unknown packet means you do not have destination IP address information in your leaf kube database or you leaf in the point database. Okay, so leaf always maintain two table, local table, local endpoint table, and remote endpoint table. Okay, so what is the remote, what is the local here? A local means suppose you have EPA, right, which is directly
Yeah.
connected. This is EPA. There is a separate command which you can run in your device. Okay, what is the remote table here? Suppose remote is EPB, right? So suppose you do not have EPB entry here, you do not have EPB entry here in the point B entry. In that case, that particular packet will become the unknown unicast or your unknown packet for this leaf switch right here. So it will
Yes.
always say, okay, I have the way to reach out to you. If any packet is unknown, destination packet is unknown, what it will do here? First packet will hit in the table. This will be the your entry for local table. Okay,
Okay.
I have the VLAN 100, which is MAC address is this from coming from this. Okay, and destination MAC B but unknown, right? In this case,
Yeah.
you always, this is we call it the here if you check that, here this loopback come in the picture. Okay, leaf will always do lookup towards the kube database for the unknown traffic, right?
Okay.
So in this case, your source IP, outer source will be your leaf. What will be the destination source? What will be the destination IP? Destination IP always be multi-classed IP address, which will be the present in the bridge domain. You cannot say that ACI allowed any kind of flooding inside the fabric. It will be always multicast packet, which always we say it, uh, you know the fabric path, right?
Yes.
In the fabric path, we call it f tag, right? F tag value, right?
F tag.
F tag we call it in the fabric path. We for the any kind of re-election happen in the fabric for the multi-destination. If you have multi-destination traffic, let me show that. Uh, F tag. Okay. So here is the F tag value. Okay. If any packet come here, so by default, bridge domain will have the one multicast address. Okay, by default for the any kind of flooding. Okay, so that F tag value. So suppose you have four spine switch here. Okay, just like a root bridge. Okay, suppose you have 10 devices in your network. Out of 10 devices, suppose one device is acting as a root bridge for the VLAN 10, one is device acting as a root bridge for the VLAN 20, right? Like that, right? This is similar kind of thing here. F tag root for the T0. Okay. If any kind of TG packet coming here, and this leaf switch say, okay, I'm going to do F tag, I'm going to use F tag value. Okay. F tag, which F tag? If it is unicast, okay, then it will go for a specific F tag device here. We call it also load sharing between the leaf spine switch here. Okay. If suppose your one host is sitting here, okay, sitting here. If your unknown unicast come here, right, it will send to F tag 0, F tag 1, F tag 2, F tag 3. Who has this information, please give me. It will send you the kube lookup kind of request, right? If it is unicast, packet will come here. Okay, it will say, okay, I am the unicast. I will always prefer the shortest path. What will the ISIS matrix is 4, right? By 40 by default, right? So always it will go for the shortest path. So it can select your root T0. It can select your root T1. It can select your any other root tree here. So up to 16 root tree ACI can support. Okay, one device, one spine switch can act as a root tree for the multiple tag here, F tag values. Okay, how this happen? This is the default nature of the spine and leaf switch. You do not need to. You can modify it. Okay, you can modify it, but you can not delete this F tag values. Or if you are going to delete this F tag value, it means your unknown traffic will have the trouble here. Okay, this is the load balancing for the multicast or distribution across the 16 F tag. Suppose this F tag is root for F tag 1 and 2. F tag this route for 1 and 3. So this is how it load balance between the switch here, your traffic for the multicast forwarding. It means for the unknown traffic. Okay, so we cannot say it's a flooding. It's a kind of multi-destination traffic because of the F tag. F tag is the one who avoid the loop here. F tag always work with the ISIS protocol. Okay, F tag always advertise by the ISIS. Where ISIS run by default between the leaf and spine, ISIS work here, right? Is there any confusion here? Awad?
It's this F tag,
Mm-hmm.
the root and everything. will be used between the leaf and spine, and it will be selected which spine will become root for which F tag or which leaf. It is based
No,
on the leaves or number of
leaf.
packets.
No, no. So there is a unique F tag decision happen based on the ISIS here. Okay, who will be the spine? Who will be the root for the 0 and 1? Who will be the root for the 1 and 3? So that decision taken by the ISIS protocol. Okay, so the moment your root selection is done, your spine switch will advertise through the ISIS. Okay, to all the switches, I have this root tree information. Okay, if you can,
Okay.
this is the command. You can check that this is the by default election happen through the ISIS protocol. Okay,
Okay.
is it clear?
Okay. Yeah.
So I will show that practical also. Okay, no worry about that. I'm just giving the wider or high level picture of your ACI, because this is the a thing which we need to understand before going for any kind of practical or design, right? How the our packet flow here, how unknown packet flow between the leaf and spine, how the known packet flows, right? You got this point, right?
Yes.
So okay, so sorry. So let me where we were here, I think. So this was unknown traffic, okay? Unknown traffic flooding. In the, if you have BDs in the flood mode, okay? And what if you have three L3 BD here, okay? L3 BD, gateway is your ACI, okay? You configure gateway
Okay.
IP in ACI, and your, this is the your leaf switch here. BM is directly connected, okay? This is the known, already known packet. So what will be the flow here? It's the same. Outer IP and outer header will be the same, right? Destination will be this IP, this leaf IP, virtual IP. If it is in the BPC, if they are not in the BPC, then can be the load balance, right? So
Yes.
it will come here. It will do the encapsulation. In the encapsulation, you will see the outer source IP will be the type address, outer destination will be the leaf 4 here. It will load balance here, okay? So how the things happen here? So by default, what happen here? Uh, just give me a second. So here you will have, sorry, something is weird. Okay, so here I have. So by default, what's happened here? Suppose you have the remote entry and the local entry. Remote entry you already have for the 2.2 dot, right? 2.2 dot. In the table, in the route, in the forwarding table of your leaf, you will see the one VXLAN terminal. Okay, like this. VXLAN terminal, which has a timeout time like 90 second. Okay, in every 90 second, they every time they just recreate the terminal. So between the leaf and spine, if it is known packet, it will travel through the VXLAN terminal that we call it EBPN. Okay,
Okay.
so that terminal, you will, if you will see the in the leaf switch here, so terminal interface, you will see bunch of the remote terminal. You will see here terminal always create for the remote entry. Okay, if you have remote entry, then how this switch and this switch will communicate through this VXLAN terminal here. In the Nexus switches, if you want to configure the VXLAN, you need to configure the terminal manually, right? VTAP and tab, VNID, everything you need to map it manually. But in ACI, everything take care of these terminal, all the things take care from the EBPN. Okay, Ethernet EBP, Ethernet VPN. So
Okay.
this is how the tunnel works here. This is how the packet works here. This is for the unique ask. What if packet is unknown for L3? Okay, suppose packet is different BD. And just give me a second. This is already known. Uh, okay, so this was the same subnet. Okay, this was not same subnet. Two different subnet forwarding. This is unknown traffic. Yep. IP packet inside PRF ID. Okay, so what will be the packet flow of this packet? Packet will hit here. Okay, it will. So okay, I'm part of the VX. This particular IP address. This is the gateway. It will send to your spine switch. Spine switch will do the lookup. It will check. Okay, okay, I have already entry for this. Go for this leaf
Mhm.
and talk to this particular subnet. Okay, what will be the L3 forwarding? Source IP MAC address. This is the decapsulation packet. Okay,
Okay.
of your leaf switch here. It will check the L3 forwarding table. It will see the source IP and learning VRF in BD. It will check the destination. What is the destination? What is the source is coming from? Okay. It will check the VXLAN packet here with the ID, the VRF ID. It will check the last hop switch MAC override here. What is the, because the moment packet will hit, it will do the entry, right, for any packet here. So these are the a few things which always leave destination leaf install in the table here.
Okay.
Okay. Is it clear? Any problem here?
No, clear.
This is just a known packet. Okay. L3 known packet. And this is unknown packet, L3 unknown packet. How the L3 unknown packet works here. Okay. So in ACI, something we call it a hardware proxy. Okay. So it means if your packet is unknown, your this leaf switch, spine switch builder will perform the proxy here for the routing information.
Okay.
Okay. So if your packet is coming here with the destination IP address of the this particular spine spine IP address, right? In the destination, you can see here Anycast spine here, right? So Anycast IP will be the destination for this packet up in the outer header. Okay. If will spine will receive the packet, it will send the packet to the leaf 4 and it will say, okay, I am the use my IP as a source IP, oh sorry, as a destination IP for this particular host. The packet will hit here. So spines will say, okay, I do not have information for leaf 4, or if I have, no problem. If I do not have, just use destination as a source IP, and this will do the kube lookup in the spine table. It will do the kube lookup, and it will send to the particularly a leaf here, because spine will have the all the information from the leaf here because of the kube table here. Okay, so spine always know where what packet is where. Okay, if spine doesn't know anyone, then packet will be dropped. Okay, packet will be forward here. Leaf switch will say, okay, I do not have destination IP address. I'm going to send to my proxy device here. So it will send here proxy device here. Okay, it will say proxy tap address I'm going to use as a destination. I'm going to send here. Spine will say, okay, I have this particular leaf 4 information in my table. Okay, I'm going to send here packet here. Okay, then packet will return here. It will return here. Then it will return here. So in the return packet, your leaf will install the entry of the remote endpoint or you can say leaf here. Okay.
Okay.
Since the packet is not written here, it will switch will not know any destination IP address except this tap address of the Anycast spine. This is just unknown. So who is the acting as a middleman here? Your spine switch here. So spine switch even Anycast is unknown. Your traffic will be still sent to these devices, any remote devices. You can say that. That we can achieve using the spine proxy feature here. Okay. This usually we use for the L3 traffic. Okay, we usually use flooding for the L2 traffic, and we use proxy for the L3 traffic. This is the default feature we can say. You can disable it, enable it, okay? If you don't want to proxy it, if you don't want to enable proxy, you want to disable it, it's up to you, okay? It's your choice. But there is a certain combination, like if you're not enabling the proxy, how traffic will work. If you're enabling the proxy, how traffic will work, okay? Okay, this is the in the point lookup, a leaf perspective if packet is unknown, okay? If we'll see the here, packet is unknown, what it will show here? My next hop is your spine. Overlay is your spine, okay?
Okay.
For any destination, this is the destination IP. It will always say, okay, I don't know, but I have spine information where you can go it, right? Then spine will say, okay, I have the destination IP information, okay? So this is how the known and unknown packet works here, okay?
Okay.
And yeah. So this is how the this is the your normal L2 L3 packet works between the BMs, okay? Between the virtual machines. I'm not talking about even the L3 out. So okay, so about let's take like 5-minute break, okay? I will come back again.
Sure. Okay.
Okay.
Okay, Vijay. Thank you.
Okay.